All right, so we've agreed that question number 1 is B, if you've got the white sheet, and it's question number 2, if you've got the green sheet, and it's also B. If you're doing the conversion one, 80 kilometers an hour to meters per second, the correct answer is A if you've got white. It's, which question is it if it's green? Number 4, and it's C, right? And it's divide by 3.6. There is no excuse for not getting that right. I told you what the rule is. Kilometers per hour to meters per second is divide. I would guess out of the almost 50 kids that wrote this test, probably, I'm going to guess, somewhere around 8 did it the wrong way. I have no answer for that. Okay? You got to know which way to go. If you are one of those people, make a pledge to yourself to fix it. If you have your cheat sheet with you, go and find it on your cheat sheet right now and fix it. Okay? Fix that problem. It is divide by 3.6. Okay? That is a gimme mark. Given this position time graph, the one that goes down like that, what type of motion is this? Because it's below, that's going to be what kind of velocity? Negative velocity. And because it's slowing down, flattening off, then that's positive acceleration. So that one is B if you've got the white sheet. If you've got the green one, it's also question number 3, and it's A. Okay? And that was in that handout on the ticker tape stuff, right? The ticker tape stuff. The last one, given this velocity time graph, what type of motion is this? Number 4, because it's flat velocity, it's above, right? That's positive velocity, but no acceleration. So that's D. And I'm guessing that's number 1, and that answer there is C. It's positive velocity, it's above, no acceleration, it's flat. Okay? Most tests you're going to see somewhere 2, 3, 4, 5 multiple choice questions along that nature. Connor, less visiting. We're going to talk about number 5, white, which is number 10, green. Okay, so given this position time graph, we'll calculate the following. I did tell you, when you're looking at graphs like this, the number 1 thing you need to look at, the first thing you need to look at is, what kind of graph is it? This is a position time graph. It shows position. Question A, delta x refers to the change in position from 0 to 3. And I'm just quickly going to draw the graph here. It goes like this, and then it goes way up like this, and then it's flat, and then it's kind of down like that. So change in position from 0 to 3. 0 to 3 is this portion right here. It starts at 0, and it goes up to 1. The position is what we are graphing here. So your answer is plus 1 meter. It's a graph of position. We are asked for position, so we just read it off the graph. B, V bar during 3 to 5. 3 to 5 is this stretch right here. Okay, V bar, the velocity on a position time graph, is the slope, and so we are to find the slope. There was the occasional person that still doesn't know how to find slope. There was the occasional person that had their y and their x backwards. You got to solve that. If you're one of those persons, make a note of that on your test. What you did wrong. Okay, so this point right here is at 3, 1, and this point right here is at 5, 8, right? Mm-hmm. Find the slope. It's y over x, change in y. 8 minus 1 is 7. Change in x. 5 minus 3 is 2. 7 over 2, 3.5 meters per second. I would strongly urge you to put meters per second. Put your units in. Okay? And show your work. If you show me something like, if you had 5 minus 3 all over 8 minus 1, like if you had your 2 and your 7 upside down, I would probably give you half a mark. You know how to find, you know that you have to find slope, you just don't know how to do the slope. But if all you give me is an answer, okay, the answer is not the most important thing. You've got to get that out of your head. The process, and I need to see it. Okay, and that is my job over the next 2.5 more months, is to train you to do that, and you will get better at it. Okay? All right, V inst at 7 seconds. 7 seconds occurs right about there. V inst, velocity is slope of a position time graph, and clearly the slope here is 0. Oh, by the way, A, B, C would be very helpful. Okay, so the slope is flat at 7 seconds, right there. We're not talking about the value of 8. This is not a graph of slope, this is a graph of position. I need slope, 0. And D, during which intervals is the object moving to the right? When is it moving to the right? When it has a positive slope. And when it has a positive slope is that one and that one. And so it's interval. And I was amazed how many people put 1 to 3. How many people put 1 to 3 in here? In fact, I even did it on my answer key. And I thought to myself, why did I do that? And then I looked, and a lot of people did that. Can anyone tell me why they went 1 to 3? No? I didn't mark anybody wrong for it, right? But it starts right here at 0, right? 0 seconds. From 0 to seconds to 3 seconds, and then from 3 to 5. That was the answer. Okay? I'm going to pause for 6 is the same as 17 green. Okay? All right. Now, you should have expected one of these questions on the test. Now, you'll notice that I've got it marked out of 3. I changed that to 6 because these are clearly worth more. Okay, so they're 2 marks each. And yes, they are hard. Okay, so a girl gets on a bike and rides at constant speed down the street to the corner store. Along the way, she stops for a red light. When she gets to the store, she goes inside. On her return, the light is green. All right, I like to start with position time graphs. Now, you have to figure out where the frame of reference is. Generally, it's wherever you start. So she's riding along, she's starting at 0, she's going at a constant speed. If you put a little curve there to get her up to constant speed, that's fine. But generally, your line should be straight. Okay? Along the way, she stops for a red light. So she has to slow down, and her position remains unchanged. And then she continues on to the store. And then she goes in the store, so she stopped. And on her way back, the light is green. On her way back to her original position. Okay? So many of you continued this farther up. She comes back. That make sense? Yeah? Okay, so that's position time, dt. All right, velocity time. Is the velocity ever going to be negative? Yeah, on her way back, it's going to be negative. Right? So she's traveling at a constant speed, which means the velocity remains the same. Then it drops down to 0, and then it goes back up, presumably back to her original speed. And then down to 0 when she's in the store, and then negative on her way back. Does that make sense? Okay. Most people I tried to indicate on their test what they had done wrong, or circled an area where they were wrong. Give you a clue. Now, acceleration is challenging. There's no doubt about that. Okay. This is probably one of the hardest questions on the test. The acceleration is the slope of this. I can show you right on here what the slope is. What's the slope right there? 0. Slope right here? Negative. Slope right here? 0. Slope right here? Positive. Slope right here? 0. Slope right here? Negative. Slope right here? 0. Negative? 0. All right, so graph those values. So graph 0, negative, 0, positive, 0, negative, 0, negative, 0. When you do it that way, it's really pretty simple. Okay? And I did show you that. Not an easy question, though. Okay? So 2 marks for each one. Okay, number 7 was not done as well as I'd hoped. Number 7 is what is uniform motion. It's the same as number 8 on green.
Yeah, I don't know at all.
Okay. Uniform motion means constant velocity.
I said that.
Okay? If you said velocity increasing at a constant rate, that's uniformly accelerated motion. Uniform motion means constant velocity. Give an example. would be something like a car cruising on a highway at 100 kilometers an hour, right? And what would the graph, a VT graph look like?
Just straight line.
Flat line, not straight, flat line. Uniform velocity, constant, uniform motion, constant velocity. Okay?
But
Number 8. Okay, number 8. Granted, this one was a bit of a challenge. This was from way back. Okay? Somebody help me out here. 12? Okay. Yep, 12. 8 and 12. 8 and 12 green. What 3 things must be present to give an object's position? You need an origin or frame of reference. You need a distance from origin. And you need a direction from origin. Okay? People try to equate it with velocity and motion and stuff like that. They're just talking about the object position. Where am I in relation to some frame of reference, some origin? And unfortunately, that's, 3 marks. Most people got 1 or something rather than I was a little bit generous with distance. Okay. Number 9 is the bowling ball. Number 9 is the bowling ball. 13. Okay. All right. When you're doing a question like this, I cannot stress enough the need to write the formula. When you show me the formula, you are telling me you understand the process. I don't care about the answer. I want to see your thinking process. Okay? It's vital. Okay? That may be different from what you're used to, but that's what I need. Okay? So let's write out what we do know here. A bowling ball leaves the hand of a bowler at a speed of 2.6 meters per second. When it reaches the pins 1.1 seconds later, it's traveling at 2.15. What is the acceleration? I'm solving for A. I'm solving for A. The 2.6 is what speed?
Initial.
It's my initial velocity. My initial is 2.6. The green one here, sorry. The final is the 2.15, and the 1.1 seconds is my time. Okay. You'll notice that it's worth 2 marks. That's a pretty good indication that I'm going to need to see 2 formulas. Okay? To find acceleration, I am likely going to need A equals delta V over delta T. We have the T. Do we have delta V? We do not. I have VI and VF. They are not the same. You've got to get these velocities straight in your head. Okay? That is the number 1 mistake in this unit. If I don't have delta V, I have to solve it first. Use an eraser and move that over. Okay? Many of you will have something like this. You'll have something over here, and then you'll have me with an arrow like this. How come? Because that's the order it has to be. Okay? We do not read from right to left here. We're not Chinese. Chinese people and Hebrew people read from right to left. English, we go left to right. Please put your solution left to right. Use the eraser. If you're still using a pen, stop. I have this luxury, I can do that. All right, the first thing you do is find delta V. So you write delta V is VF minus VI. You gotta write the formula. I write it, and I can do these questions in my head, you guys. You gotta write the formula. And I have to do them every semester. Very good, Nick. Did you hear what Nick said? So 2.15 minus VF minus VI, that's 2.15 minus 2.6. And you get a change in velocity of negative 0.45. That's the first thing I look for, and do they have a formula? Notice, please, how I've got my formula vertically, not like this that so many of you like to do. Drives me absolutely nuts. You put the next line like this, and then you put this one way over here. I don't know why you do that. Stop it. Okay? Line up the equal signs. Like that. Okay? Then, this one goes right beside it. Delta V is going to be minus 0.45. Delta V minus 0.45 divided by my time 1.1, and I get an acceleration of negative 0.409, and that's meters per second squared. Number 10, how long in seconds does it take a car to accelerate from rest to 55 at 3 meters per second squared? 14 is number 14. So 10 is equivalent to 14. You'll notice once again that it's worth 2 marks. A strong indication that there are 2 steps. If all you did was take 55 and divide by 3, is that 2 steps? That should tell you that you've missed something. And what have you missed, my friends? 55 divided by 3.6. And show that. It takes just, like, what did that take me? 2 seconds to write? Show it to me. Show me how you got that value. Okay? 55 divided by 3.6 is 15.3. Now we're going to go A equals delta V over delta T. The acceleration is 3. Now, do I actually have delta V? Technically, this is the final velocity, right? How come I can use 15.3 in there?
The initial is 0.
The initial is 0. If it goes from 0 to 15.3, how much is it changed by? 15.3. There might be some purists out there that would want you to go delta V is VF minus VI. Delta V is 15.3 minus 0. Delta V is 15.3. That's a lot of work for nothing, is it not? Can I just say, yeah, we don't, I know you can do that, right? But it only works when what? The initial velocity is 0. And that's important. Okay. Now, unfortunately, there are some people who still are struggling with solving an equation like this. Okay? This has to become automatic. It has to. The t goes where? There. It's on the bottom already. It goes there. The 3 goes there. That has to be automatic. And the only way for that to be automatic is if you do lots of those. If you haven't done enough of them and gotten them right, if you do lots of them but you don't check your work, guess what? It's like Nick shooting at the net, but doing it blindfolded. He doesn't know if he's hit the net. Okay?
Yeah, you will. 'Cause you'll hit
Well, okay.
the scores.
Sure, prove me wrong. Okay? You got to check your answers, and that's why I give you answers. Okay? T is 15.3 over 3. Your time is 5.1 seconds. Again, notice vertical, up and down, answer or equation signs lined up. It's important. Okay, number 11. A ball is dropped, 11 dropped from a cliff. 9? I'm told it's 11 is the same as number 9. A ball is dropped from a cliff. The acceleration due to gravity is minus 9.8. If the ball lands after 5.25 seconds, what is the final velocity, VF, when it lands? You'll notice once again how many marks? 2 marks. How many steps? 2 steps. What do we know? We know acceleration is equal to minus 9.8. We know the time is 5.25 seconds, and we are solving for VF. One thing that is not said is what the initial velocity is, but it is said when I tell you that it's dropped, and so that means my VI is
0.
My VI is 0. Okay? So this one here, I'm a little bit of a stinker on. I want to see minus 9.8 is delta V over 5.25, and then you write delta V is equal to, and it's actually minus, I didn't worry too much about that in this one, minus 51.45 meters per second, but because it's 2 marks, that should be an indication to you, Connor, that I'm looking for something else. What am I looking for? I'm looking for the realization that VF then is minus 51.45. I need to see that If all you write here is V, that is wrong. It is not V. It is the change in velocity. That's important. I'm checking to see if you understand the difference. Okay? And that's so important. If you write just V, you're guaranteed to be wrong because there is no formula that just has V in it. Okay? All right, number 12 is a graph one. Ben's going to help us out. 12 and 15 are the same. Given the position time graph. Oh, you know what? Oh, this is that crazy question that I realized when I was marking was the same as number 5, isn't it? The only difference being the graph. So you had another chance at getting some marks here. 12 and 15 are almost the same. They're exact same question. Okay.
There's 3 of them like that.
Really?
Yeah.
No.
I'm pretty.
No, the next one's curved. Yeah, I thought that too.
Same.
Yeah, but it's curved. Okay. So again, graph looks like this. Okay. So delta x from 0 to 3 again is from there to there. So it's going to be from 0 to 8. So your answer for A is plus 8. Right? V bar from 3 to 5. That's the slope of this line here. It's from 8 down to 1. So it's your y change is 1 minus 8. And your x change is 5 minus 3, which is minus 7 over 2, or minus 3.5 meters per second. The instantaneous velocity at 7 is a little bit harder than the other one because it was 0 in the other one. At 7 seconds, instantaneous velocity, we're talking about slope. So that's going to be 3 minus 1 all over 8 minus 5, which is 2 over 3, or 0.67.
So 8 minus 1.
8 minus 5, right? And again, which intervals is the object moving to the right is when it has a positive velocity, so that's going to be there and there, right? So in this case, it's going to be 0 to 3 and 5 to 8. Number 13 is the drag racer. Drag racer, Ben?
18.
18. 13 is the same as 18 in green.
Oh, that bonus?
Okay, so 13 is number 6, yeah. There's 2 drag racer ones, okay.
Oh, man.
So a drag racer has an average speed of 175. How many seconds does it take to cover the 200-meter track? 2 marks. Connor, again, what does that indicate? 2 marks indicates?
2 months.
2 different things.
2 different things I'm looking for. 2
That's
steps.
good.
So what is the one thing? Well, once again, it's 175 divided by 3.6. Show me that work. 48.6. We're solving for seconds. V bar equals d over t, right? It has an average speed. Average speed is v bar. So 48.6, 200 meters. Again, the t's on the bottom. Cross them. It's got to be automatic. It has to be. You can't waste time, and you can't afford getting questions like that wrong. 4.1 seconds. Please note how my solution goes up and down. Not twisty. I think everybody got was the sprinter finishing the race. 14, sprinter finishes the 200-meter race.
11.
Is the same as 11. So V bar equals d over t. The displacement is 200. The time is 20.82, giving us a velocity of 9.6 meters per second. Again, straight up and down.
Which 14 and 11?
14 and 11. How are we doing for time? Lots. Okay, 15 is another graph one. 15 is the position time graph that's curved. Position time graph that's curved. Curved down. That's the one.
7.
7. 15 is the same as 7. 15 is the same as 7. Given the position time graph below, calculate the following. Delta x from 0 to 10. Now, this one, again, because it's curved, is a little bit different. From 0 to 10. 0 to 10 seconds, okay? So, what's the position there? 6. What's the position there? 0. How much does it change by? Oh, sorry, it's 0 to 10, isn't it?
0 to 1. Yeah.
Correction there. It doesn't go to 0, right? It goes to, I think it goes to 1, you're right. The whole thing is kind of to 11, right? Yeah, the whole thing is to 11. Isn't it?
The whole thing's 13.
No, oh, I guess, okay, yeah. It drops below, right?
Yeah.
Fair enough, it drops below. To 10 is only to 1 second, though, right? So my change in position is going to be 6 minus 1 or minus 5. Sorry, it wouldn't be 6 minus 1, it would be 1 minus 5. 6.
Oh, that.
It went down 5, right? It dropped 5, minus 5. V bar from 0 to 10. V bar on a position time graph, you draw not a tangent line, a line connecting the two, Alex. Connor needs to watch, Alex. Okay? And so you're finding the slope of that line. The position here is 0, 6. The position here is 10, 1. Y over x. This is the y. 1 minus 6. All over change in x. 10 minus 0 is 5 over 10. In fact, it's minus 5 over 10, or negative 0.5. Negative 0.5 meters per second is the slope. Yes? Nod and say, now I get it, Mr. Mann.
I get it, I just didn't put negatives.
Yeah, that's important. Yeah. V inst at 7 seconds. V inst, the instantaneous velocity at 7 seconds. You're finding the slope of the line at 7 seconds. The only way to do that is to draw a tangent line. If I don't see a tangent line drawn, you ain't getting the mark. It's very simple.
I don't like to.
You've got to draw a tangent line. Okay? And pick 2 points. My answer is about minus 0.67. I took many different values as long as I saw a tangent line.
Yeah. All I need is
And D, does this graph show uniform or variable motion? Because the velocity is changing, it is known as variable motion. Variable. Number 16. This is a velocity time graph. Oh, sorry, 16 is the velocity time graph that says place answers in the space below.
Oh, that one.
Okay, so 16 is 16. Now, my friends, when you see a big giant space, that means I want you to show your work there. I do not need your answers scrunched in 2-point font in there. I've taken these questions and I've had to scrunch them down even more than before because people want to put them in there, okay? It turns out I'm going to have to make it even smaller font, apparently. Okay? I do not want the work scrunched into that little 1 square centimeter of space when you have a veritable hectare of space down below.
That's a whole hectare.
I exaggerate a little bit. Please use the space and use the system of A, B, C, and D. I can follow that. Okay? I didn't mark anybody wrong, but I had to get out a magnifying glass in some cases. Stop doing that. Okay, now to the physics. Here's the graph. It goes down like this, and then it's 0, and then it's up, and then it's back down again, and then it's curved, right? Okay, and this again is a velocity time graph. Okay? So A bar from 3 to 5. From 3 to 5 is this section right there. It's a velocity time graph, so solving for acceleration means slope. What's the slope of that line right there? 0. The slope is 0, it's flat. The slope is 0, it's flat. B asks for the average acceleration from 11 to 15. That's the curved portion. It's from there to there. It doesn't actually go all the way to the axis, does it? It goes to there. Okay? So I'm finding the slope of that line joining those two. So it's minus 1 is up here, and this one is at minus 5. So it's minus 1 subtract 3. Minus 1 subtract minus 5. Does it not go up 6? Sorry, 4. 1, 2, 3, 4, right? And it's over 15 minus 11. So it's up 4 and over 4, giving us a slope of 1 meter per second squared. 1. And that's exact. That's not, like, there's no tangent there. It's connect those 2 points. Okay. Now, how many people noticed that C was worth 3 marks? Which means likely it's not just going to be one quick little calculation, right? 3 marks. Delta D from 0 to 8. How do we find displacement on a velocity time graph? We are talking about area. So you find the area of that triangle there. The area of that triangle is base of 3, height of minus 3, so it's 3, or minus 3 times 3 divided by 2, minus 4.5. I looked for minus 4.5. Okay? Show your work, and I will give you marks. Do not show your work, playing with fire. Now I need to find area of this rectangle here. It is 2 by 3, minus 3 actually. 2 times minus 3 is minus 6. I look for that number. This little triangle right here, now I have to admit, it doesn't look like it goes right through 6. I did not teach you what to do, what happens when this happens. And so I was very liberal with my marking here. Most people assumed it went through 6, which was fine. So it gives you a base of 1 and a height of minus 3, giving us a minus 1.5. And then above is this right here. Lots of people did this. That is wrong. It's the area between the graph and the time axis, okay? The graph and the time axis. Minus 1.5. Is this one? The one above here is 6 to 8 is 2. Height of 7. So it's 2 times 7 divided by 2, which is plus 7. So now you add those all up. Minus 4.5 and minus 6 is minus 10.5. Minus 11.5. 7. I guess that's 12. Minus 12. And 7 gives me minus 5. That's my answer. 3 marks. Lots of work there. Gotta show the work. Let's go to D. D is A bar from 0 to 8. 0 to 8 doesn't even exist on the graph. You have to draw a line from there to there. And I have to see it. Draw that line. It's acceleration. Acceleration on a VT graph means slope. So find the slope between those 2 points. Okay? And that slope is up 7 and over 8, or 0.875. E is the instantaneous velocity at 13. Again, it's a velocity time graph. Acceleration is slope. So I need to find the slope at 13. Because it's a curve, I can't do it without drawing a tangent line. In other words, without a tangent line, no mark. Okay? So I get approximately 1 meter per second squared. That's what that little squiggle equal sign means, is approximately. when you find the slope. If I saw a tangent line and a proper slope calculation and a value around 1, I gave it to you. V inst at 12. Instantaneous velocity at 12. This is a graph of velocity. How do I read instantaneous velocity? Read it off the graph. Pick the value at minus 12. I said it was minus 4.7, but I took anything around minus 4.7. You had to say minus, though. G I left out. Okay, G is basically the same question as C, but it makes it harder because it's not going through that point between 9 and 10, and so I made an executive decision to just not mark G. Last one, 17 is likely the easiest graph question on the test, and for whatever reason it always messes people up because they want to make it harder.
Yeah, that was like our first one.
It was your first one?
That was 5.
5? 17 and 5? It's a position time graph, and it asks for position or for displacement. So position time graph, you read it off the graph. From 0 to 4, 0 to 4 seconds is this one here. How far does it go? It goes from a position of 0 to a position of minus 5, and so the answer is minus 5. Okay? B, from 4 to 7. 4 to 7 is right there. Position time graph. It goes from minus 5 up to minus 3. That's a change of
2.
plus 2. 0 to 7. I gave you 3 questions like this? Holy moly. 0 to 7 is that change there. It starts at 0 and it ends up at minus 3, so that's a change of minus 3. And then V bar from 0 to 11. On a position time graph, the slope is the velocity. So from 0 to 11, I'm finding that slope there. So that's up to and over 11, which is 0.18. Sad to say that no one got the bonus. I don't think. Did anyone get the bonus? Did Luke get it? Yeah? A drag racer accelerates at a uniform 1.7 meters per second squared. How far does it travel during the 7th second? During. So 0, 1, 2, 3, 4, 5, 6, 7. Which one is the 7th second? There's the first one, the second one, the third one, the fourth one, the fifth one, the sixth one. The 7th one is between 6 and 7. How far does it travel between 6 and 7? So I need to find out the average velocity between 6 and 7, and the only way to get the average velocity between 6 and 7 is to find out how fast it's going at 6 and 7, and then find the average. So how fast is it going after 6 seconds? 1.7 is delta V over 6. So at 6 seconds, it's going to be going 10.2 meters per second. How fast is it going at 7 seconds? It's going 11.9. A lot of people wrote 11.9 for their answer, right? But that's how fast it's going at that time. So what's the average velocity between those two? 10.2 plus 11.9 divided by 2, 11.0, right? Okay, 11.05 meters per second is the average. And then you go V bar equals D over T. You take that number. And the time interval from 6 to 7 is how long? 1 second. Yeah, there was one person that got this, I remember. That's a hard question, but it's bonus. One of the things that I'm doing in my grade 12s is doing a bit of a test analysis, right? What are the big ideas here? Well, certainly, one of the things you can look at is position time graphs. Okay? go through your tests, and I'd like you to do this. Is there room on the back? Yes, the white ones have room on the back. Do the green ones have room on the back? Awesome, okay. So go to the back of your test, and I'd like you to write down PT graphs, VT graphs. What is one other sort of big idea on this test? A theme. Well, okay. Like, if you had to categorize the questions, there's PT graphs, there's VT graphs. Would you say there's word problems? Word problems / formulas?
Yep.
Okay. Word problems / formulas. Anything else in here? Like the multiple choice is just sort of, theory, multiple choice kind of stuff, right? What about drawing graphs? Right? Drawing from a story kind of thing is what I call it. Drawing from a story. Okay? And anything else would be like, we just call it theory. The rest would be kind of theory, right? Like all that multiple choice and what three things must be present given an object's position and the uniform motion. We'll call that theory / definitions. How's that? Okay, so what I want you to do is I want you to go through your test, take every question and put it under one of these categories. Okay? And I want you to write down what score you got. Okay? So I'll do the first one for you. Everybody has theory and definitions. You have the first 4 questions, right? All agreed? So theory and definition would be questions 1 to 4. And tell me what score you got out of them. I got 4 and a 4.
What about those other?
Okay, yeah. So questions 1 to 4. If you've got the white page, then number 7 is the uniform motion one. And number 8. And are there any other theory questions? I think no. Okay, so what did you get on number 7 and what did you get on number 8? You green guys are going to have to figure out which ones those are, right?
12 and 8.
12 and 8? Okay, so tell me, what did you get on 7? 3 out of 3. What did you get on 8? 2 out of 3. Okay? I want you to do that. Every question has to be categorized under one of those things. PT graphs, VT graphs, word problems, formulas, drawing from a story, or theory definition. Okay? When you do this, you should be able to do what? When you're done, identify what things?
The bad things.
What you do good and what you do bad. Don't study what you do good, study what you do bad. Learn what you did bad. Okay? I want to see this tomorrow. This is your homework for tomorrow. I want to see that back page for tomorrow. Okay, you got a few minutes right now.